Good afternoon, everyone. Welcome to a new session, Artificial Intelligence, and how can we use it in our SQL Server DBA activities. And we just need to confirm that how and what. Okay. Uh, from the past years, we were using SQL Server, and there afterwards from 2000, 2005, 2008, R2, 8R2, 2012, 2014. And apart from that, the major change in database architecture has joined us in 2012. There are many new opportunities, many new features available over there. And after that, we started learning SQL Server in an efficient way. Okay. Uh, okay. How efficient? We used to have a normal installation of SQL Server or any repetitive task. We have involved PowerShell into it. PowerShell is available for us from the year of 2004 only. Okay. And the date afterwards. Now it's time to change it. Now we just have to add an advantage for our DBA daily activities. Okay. Artificial intelligence is not going to eat our jobs, but it will be replaced by a person who learned AI. That's a simple scenario. Okay. What is artificial intelligence? Let's start with the basic. It's a branch of computer science, or else we can say it. We have made our computers to learn, reason, problem solving techniques, and decision making. Before that, these capabilities were not there for computers. Okay. In the same way, simple. There are three pillars of basics of artificial intelligence. Are we have to make our computers to learn, to think, and to make a decision, and to capable of making a decision. These are the 3 points in which artificial intelligence going to start its journey. That's okay. Then where it is available and what are the types of AI available over here? How does it works? Very simple. Data collection, pattern recognition, and continuous learning. Data collection. In I will be completely speaking in a DBA perspective only. Okay. For example, we just want to analyze or plan how we use AI. How can we use AI for CPU capacity planning? Okay. For that, we collect the CPU usage completely for every 2 seconds or 3 seconds, depending upon its usage. We collect how our CPU is performing. Once that CPU is done, in the next point, what we do is pattern recognition. Am I audible? Are any disturbances? It's a resound is coming. Okay.
Rakesh Shivan, can you please unmute yourself?
Now it will be. Okay. First thing is data collection. What it will do is it will just collect the details how our CPU is performing. From where do we collect the details? First thing, the basic thing is we will be using DMVs, right? DMVs will hold the data how our server is performing in an simplest manner. Okay. If not, we want to collect more details, we are just going to create a table and collect the details and insert into it. That's the second scenario. Third scenario is create an extended events, right? But it is available from 2012. Actually, extended events are available from 2012, before that only 2008 R2 only, but the GUI methodology was not there. Now it's available, but the best thing is using extended events. Why? Because they are lightweight monitoring tools. It's very lightweight monitoring tools which will triggered upon event only. Okay. First thing is data collection is completed. How we do it? We can do DMVs. Point one step methods. First method is DMVs. Second method is extended events. Third method is using collecting the data and storing it in a table. Okay, this is one. Second thing is pattern recognition, which we called it in AI terminology. We called it as an anomaly. Anomaly. What does it mean? For example, if you open a Google Maps and you can see the distance between one source to a destination, it will give you a time. For example, for you to travel 60 kilometers, it will show you 1 hour. How it is 1 hour? Very simple. 60 kilometers is an mean average speed to be maintained over there. Okay. Leave it. For example, a human heart is there. It will human heartbeat has some 70 to 110, and the average is 70. All of a sudden, if your heartbeat raises up to 150 or 160, then that is an anomaly. There a trigger is going to happen. Third thing is continuous learning. Okay, this continuous learning, where we can implement it in our query tuning abilities, self tuning abilities. Okay, it's keep on, and this option is already available in SQL Server, but we don't call it as an AI. Okay, query store will just copy the store the query plans, but it does nothing until and unless we force fail over the plans. Okay, next comes types of AI. Okay, first thing is narrow AI, which is a very simple thing, which is a Siri in your iPhones or Alexa or Google. What do we say that? Okay, Google in our daily activities. Thereafterwards comes the machine learning. Okay, this is machine learning. Is it makes the capability of thinking beyond the box. Explicit programming is involved here day to day. It keeps on learning and then tries to improve it itself. Next comes the deep learning. Okay, deep learning. This is the majorly used over here. For example, as image recognition, speech recognition, and autonomous vehicles, just like a Tesla. And fourth comes this general AI, which is in theory only. Okay, now come. First coming is AI in our daily life. What do we do in daily life? We have smart devices, we have voice commands, just speaking with our Alexa or Siri, facial recognition. This is used in Digiyatra for in airports, right? Intelligent photo enhancement, what we use in our chat GPT and Gemini. Social media, content feeds with whatever we get in Instagram reels and all those algorithms are over there. E-commerce, product recommendations, dynamic pricings, chatbot, customer care service are all machine driven in e-commerce. Machine learning in e-commerce. Okay, even a chatbot comes in e-commerce in AI only. Okay, why AI matters to SQL DBA? We have to upgrade ourselves as per the market. If not, market will leave us. Okay, for example, you will go to an interview, or else you want to prove your abilities, you want to revamp the organization performance structure, then what do? The only thing is that First thing, in years back, almost 10 or 8 years back, we used PowerShell to automate the things for installing SQL Server and all the other things. Now it's time for us to implement AI into it. To implement AI into it, reason is that we can say bye bye to our manual monitoring, tuning, and maintenance. For example, anybody can answer if there is a disk space alert, what do we do? Or else, if there is a high CPU usage, what do we do in our daily life? Anybody can speak. Simple. We just get an alert, right? In that alert, we join. We just look at the alert. We just log into that server, and that time we need to find out what exactly is happening over there. Then we need to do it, right? Or else, a simplest way is blocking. What do we do, or how do we get an alert? What do you do when a blocking occurs? We just get an alert. We just write down a criteria. If blocking stays in the machine for more than 5 minutes, we should get an email, right? Email. Then yes, we got an email. We log into that server, then start working on it. What exactly is happening over there? Once that is done, we just go to decide what needs to be done to resolve this blocking. Okay, but third thing is, how many of you on a daily or a regularly or a bike with anytime have you ever read your error logs on daily basis? Do you ever read your event viewers? Did you ever collected the cluster log if you have SQL cluster configured over there? If you ever created the cluster log and read it, we don't do it. Why? Because we are just like firefighters. Okay, we will start to work when there is a fire in the city, right? That's how a traditional SQL DBA used to work. But now as a modern or a new generation or a next generation SQL Server DBA is equipped with AI. Okay, here I give you a real-time scenario. We have an archive jobs running in our server, archive jobs, which will just move the old data into the unnecessary unrequired data into another table and leave it, right? Then how, unfortunately, our business runs 24 by 7. 24 by 7. But when that job runs, CPU will stuck to 50 or 60%. In that scenario, you have been given a task, or you have been asked to find out the best time to schedule that archive job. Okay, archive job. Then what we can do by implementing AI, it will just read the trend analysis of your CPU usage and suggest you a time. For the last 2 months, this is the last 2 months. On every Monday from 1 a.m. to 2 a.m., CPU was absolutely free. You can run your archive jobs on this day, on this time, at this time. And it does not mean that it is going to be the same. For next week, it will suggest you a new time depending upon monthly. Okay. Why? CPU usage may or may not impact the business, but it will surely impact the business when it is left unassigned, unidentified. Okay, by using AI, we can do this. Okay, the best implementations will be these three. First one is intelligence performance tuning. Second one is predictive anomaly detection, and third one is automated operations. Okay, when coming to the predictive anomaly detection, what we do, whether it may be a CPU, whether it may be a DV size, disk space, We can do it by using it. Second thing is intelligent performance tuning. How does this perform? You have some 300 or 400 servers or 500 servers in a single host. Think you are in a working with a VMware machine, virtual machine. In that virtual machines, you just want to find out, are this hardware okay for this environment, or else we need an upgrade. What we do, we just kind of collect the weight types of all the servers, put them in a Excel sheet, then finalize that how are they performing, and upon their performance we can decide that this can be implemented or not, used in our environment or not. For example, for a single standalone machine, if you get a weight type as CX packet, then it's where you have to work on CPU, right? This is how it can identify all the weight types and suggest you what needs to be done in the hardware level. Also, you can collect the query plan, submit it to your ChatGPT, and ask for a recommendation. That can be also done. Next comes the automated operations, that just an archive jobs which I gave you is a good example. Apart from that, apart from that, there will be many organizations, they just don't want to change anything. Okay, the only thing you can do is you can use your monitoring servers. You might be using a Foglight, Spotlight, Nagios, or any monitoring, or Grafana, any monitoring. You can just that monitoring API, integrate it with AI, and you can get your recommendations. How best your servers are performing. You can get it in that manner also. This and this is just how AI powered query optimization will improve the performance or CPU usage. By using AI query optimization, we can get down our CPU usage by 60 percentage, or automated health checks, how our jobs are failing. Okay, for example, you work by a product based company. Okay, you joined when you have joined into that new job. It's a product based company. There are more than 40 or 50 SQL servers. Once a job failed, you need to you just need to find out the flow of jobs execution. If a server one on a server one, job one is there, if that fails, what needs to be done, which job needs to be executed, that can be monitored using our AI. Everything. Okay, everything in a by using AI you can do it, but only thing is that AI works best with Python. You might get it out. Yes, I know, and I have been working on PowerShell for the past 4 or 5 years. Why can't I use PowerShell with AI? Okay, it is possible, but most of the classes, just like pandas is just like a data frame. It will collect the data and store it in it, or else Skytech, Aviva, all these, or XGBoost. These are all the classes which we have to use to implement AI in our environment. You are not going to be a programmer. You will be a DBA with a 30% skills of Python and 70% skills of implementing AI in your environment. Any questions over here? Any doubts? Let's see. Let's enable chat is enabled. You can any Any questions?
Yeah, Ramesh. Hi, Vishal ji on this side. So,
Hi.
how we can integrate like these all the daily routine jobs or daily things, like how we can integrate with the AI, or how we can like easy our daily day-to-day routines activities over there in the SQL Server DB
Okay.
or any DB.
I will. Next, we'll be looking at that one only. I have content ready over there. I'll be just showing you how this is going to be achieved, and will be with a simple examples. Till now, do you have any questions? What AI is, how AI does, what AI does? Anyone? Any? Okay, perfect, perfect. Now let's get back to the practical work. Okay, for this we just need to have Python installed in our machines. In a machine, it does not mean that you have to install Python in this server. Not at all required. Any development server or in your terminal server, anywhere you can install it. Install it, connect to that SQL server, fetch the details, and make a decision. This is how things are going to work. And can you see the screen?
Yeah.
I have Python 3.137 installed in my Windows. Okay, if you are installing Python in anywhere, all this code is going to work. It does not mean that I have written a Python program in a Windows environment. Does this program works in Linux environment? Yes, absolutely. It is just like a program. It's just a JPG file. You can open it in Internet Explorer. You can open it in ImagePoint. That does not make a difference. Okay. Here I'm going to show you a simple example. Import PyODBC. Okay, this class will import ODBC connectivity required tools. This is going to be a one-time command. Okay, just like we use install module, DBA tools, install in the same way, we are just going to install it and import it. Once we have imported it, I have defined in the server name, database name, username and password. It's not a best practice, but that's okay. You can have integrated security also. Once that is done, this is a very simple example. What it does, it is just going to connect to that machine with these details. Once that is connected, it is just going to execute, select the version and give us the details. I'm just going to execute it, and I am using Visual Studio. Most of us are used to Visual Studio only. For example, you just have a program, Python programs, and in our node we have an option called as Anaconda. By installing it, you can execute your Python scripts from web-based. From anywhere in the world, you can just connect to that, get your access. Then you can execute your Python scripts from anywhere in the world. Not only that you have to log into your Office network and do it. Not like that. That's a different story. Just any very simple import server details, define a connection string, connect with the connection string, execute a query. Here it is, execute a query, and just print the details. Print the details. I'm just executing it. Here you can see connection successful. Executing a simple query test. Executing a simple third line 39. Executed select at the rate version, and here is the query results. Here are the results. Okay, let's do one thing. Let's change it to okay. Okay, we need to change details over here. That's why. Okay, now you want to execute it in a simplest way. This is how you open the Visual Studio, open that Python program, then execute the details, execute the script and get the details. But in real time, no need to do that. We just open it in command prompt. My file is located in my C drive py files folder. What is the file name? It is test pyodbc connection. For that, for execution, py the python, then give the file name test like this. It is just directly go execute it in this manner. In the same way, we are just going to use this command, the same command, create an agent job, command prompt, SQL CMD, or else create a job in the task scheduler and make our things work. Okay, first thing. Second thing, I will just show you an example of. I just gave an example of archive jobs, right? Archive jobs, how, what is the issue we are facing and how this can be achieved. In the same way, I'm just going to give you the details. This one is completed. I have, I'll just open my file. This one. Here you see PS ODBC to connect your SQL server. PS util to fetch your CPU details. Here you can see CPU percentage details, and using that details, we are just going to update our backup jobs over here. Here we have given a job name. Here you can see, select the backup job here in the 30-second line, right? It will just query all the sys.jobs and collect backup jobs, all the backup jobs, and it will check for a slot where this query is going to execute it. What is the best time to execute these backup jobs? If you write down, if you remove backup jobs and create an archive jobs over there, just give the job name over there, then it is enough. It will work, start working for archive jobs. Okay, in this example, what it will does is it is just going to pick the CPU percentage, CPU usage for every 1 second, put it on a file, analyze it, and suggest you a best time slice, best time to execute your job. Okay, for that, I'm just going to execute this job. You can execute it directly, or else the best thing is go here, close it. Okay, this one is there, right? Python. Hmm. This will take some time. It just needs to connect to the server, collect all the details. Depending upon that details, it is just going to give us the recommendations. Okay, in this end, to make data visible, I just executed it for every 1 second. You can increase the time slice to 10 minutes or 5 minutes. That would be fine. But here in my example, to show you an example script, what I have done is I started collecting CPU percentage for every 1 second, putting it on a file, and that file will be used in this environment. That's why this job will take some time. Let's go to another job. Here you can see. I'm just going to give you an example of, here you can see. Pandas is just like a data frame. In human language, it is just like an Excel sheet. Okay, with rows and columns, cells. What it will do, it will just fetch all the details, put it on the pandas, put it on that Excel sheet data frame, and start working on it. Okay, then okay. Next NumPy is a class, date time import, PYODBC. Yes, it is the class which is used to connect a SQL Server using ODBC. Here, one question you might get: yes, I have Postgres in my environment, in my office, I have MySQL in my environment. What you need to do is everything remains the same until and unless you need to make changes over here. The server name, the ODBC connectivity differs from one RDBMS to another one. Just we need to make changes over here, and your program is ready. Now it is capable of checking the CPU usage recommendations. But one thing to do, if you look at Postgres, you don't have jobs. In MySQL, you don't have jobs, agent jobs. We have agent jobs that are totally different, not similar with the SQL Server, right? We need to make changes in that accordingly. But when it comes to the core logic, what is the core logic? The core logic of calculating the best time to execute a job, predicting the disk space over here. In SQL Server, we just use DBA, MDF, and LDF files, file groups, and all these things. In Postgres, we'll be using, or Oracle, we'll be using table spaces. Okay, that core differences will be there, but the logic of calculating the disk space, logic of calculating the DB file info, logic of predicting the CPU usage remains the same for any version of RDBMS. Okay, now just think pandas data frame. Just a second. Hello, good afternoon. Here you can see the, if you audible, did I forget to unmute it? No, right? Okay, I think you can hear me. Now, here, if you execute, if you look at this job, this task, SQL DBA, SQL job, and CPU, backup jobs, reschedule data one. Okay, it had done a perfect CPU analysis and recommended that 1 a.m. is the best time to execute your backup jobs. Okay, one more thing, if I execute the same thing as I collect the CPU details regularly, I will just do one thing. Okay, now I'm just using a PowerShell script to create some fake workload to increase the CPU usage. Think it has increased little bit, but that's enough as we are collecting the more details. Now I'm executing this job. This will take some time, but now it may or may not, depending upon the CPU usage, monitoring the CPU usage, it will recommend a new time. Why? Because as of now there is no CPU usage, right? But now I have used a PowerShell script to create a fake CPU usage. Yes, perfect. Now we can see CPU usage. We have a hit, right? Mostly it used to be less than 10%, but it is gone to 70% or 76, average of 76%. But that's okay. Let's see how this goes. This fake workload will run for only 2 minutes. No, this will take the time. Just leave. Just ig- now let's go ahead. Now get back to the third program, which is SQL Server Disk Space Predictor. What this does is, this is going to be a standalone application. It will collect to a single server, check all the databases. This one, check all the databases here. Very simple thing. Disk space collector, the same SQL query, and find out how much free space is available over there and when did it grow. That is also been calculated and give us the recommendations that for how many databases you need to increase the for auto growth, or else check the free space in your database. This one. Here you can see this is running, right? Let's go to this one. This won't take much time. Py files, Python, SQL Server space predictor.py. This is the model performance random forest it is using, and disk space prediction report, a SQL DBA, that server name, forecast for next 30 days, alert if any data files increases its size more than 80%, it is going to give us, as it's our test machine. There are no alerts over there. Here you can see disk space prediction dot csv file. Let's create check today's. This is the file which it has created. If we just collect the details, put it over here, and here you can see databases log file and its growth predictions. DBA element, these are all my databases. DBA configuration, DW diagnostics, DWQ, and test DB. Okay, as no database has grown its size, it gave us a recommendation that here prediction saved to disk. These are the prediction values which is saved to disk, which just now I have opened it, and no databases are expected to exceed the threshold. Okay, here you might get it out. Most of the people, what it is. Point one, database is there. We have executed the archive jobs. The database size has grown to 100 GB. We have executed archive jobs weekly. What it does on Sunday, it is going to move the database, move the unwanted data to another database. As archive job is executed, then database size comes down. This prediction will keep those in considerations also. It is not just a program with if and else conditions. It is just an AI program which will keep on learning the server abilities, database usage, and give us the perfect recommendations. Okay. Any questions?